going to continue with optical instrument, and we're going to look at application of lenses in our daily life. The first optical instrument that we are going to look at is a simple microscope. A simple microscope is used to magnify an image. The type of lens that we're going to use for microscope is a convex lens. The object distance when using a simple microscope is less than our focal length, meaning U is less than F. And since U is less than F, the image formed will be virtual, upright, and magnified. Alright? Virtual, upright, and magnified. Now, what happens if we were to reduce our focal length? If our focal length is reduced, it will increase our magnifying power. Alright? When F is less, our power will increase. Alright? Small f will cause a big magnifying power. So that is a simple microscope. Again, U is less than F, so that our image is virtual, upright, and magnified. And now we're going to look at a telescope. A telescope, it is used to look at a very distant object like the planets and the stars. And that is why, since the object is very far away, the light ray coming from the distant object is parallel to each other. If you see this three ray here coming in, incident to the objective lens, they are all parallel because they all come from a very distant object. Telescope, we have two lenses. We use convex lens. The one that is close to the eye is what we call as an eyepiece lens. And the one that is close to the object is what we call as an objective lens. Right. Now if we look here, our objective lens, its focal length is larger than the focal length for our eyepiece lens. Alright? Our FO is bigger than our FE. So that's one thing that you need to remember. FO is more than FE. Right. Since our object our object is at a very far away distance, which is at infinity. Since U is at infinity, the image formed by our objective lens would be real, inverted, and diminished. Alright? Real, inverted, and diminished. Now, the eyepiece lens here is used as a magnifying glass to form a virtual, upright, and magnified image. Meaning our first image is real, inverted, and diminished. And our second image is virtual, upright, and magnified. Second thing that you need to look at here is the distance between our objective lens and our eyepiece lens is equal to FO plus FE. Alright? The distance here our x, I'm going to call it as x. X is equal to FO plus FE. All right. FO plus FE. Again, telescope uses two convex lenses. The objective lens, it has a longer focal length compared to the eyepiece lens, all right, meaning FO is more than FE. And the distance between our objective lens and our eyepiece lens is equal to FO plus FE. Now we're going to look at our compound microscope. Compound microscope is used to view very small objects like microorganisms. Compound microscope also uses two powerful convex lenses. Again, the one close to the object is called objective lens, which is this one. And the one that is close to the eye is what we call as eyepiece lens. For compound microscope, our FO is smaller than our FE. And the distance between our objective lens and eyepiece lens I'm going to call it as X. X is more than FO plus FE. Alright? Now, if you look at the object here, our object needs to be placed in between FO and 2FO. Alright? It has to be placed between F and 2F so that the first image would be real, inverted, and magnified. So that it is real, inverted, and magnified. And that is why you put your object in between F and 2F. So that the first image is real, inverted, and magnified. Alright, so now we're going to compare our telescope and our compound microscope. First, we are going to compare FO and FE. For telescope, which one is longer? Is it FO or is it our FE? Correct. For telescope, our FO is longer than our FE. And it is vice versa for our compound microscope. Next, we are going to compare the distance between our objective lens and our eyepiece lens. And I'm going to call that as X, alright? For telescope, our X is equal to our FO plus FE. But for compound microscope, our X is more than our FO plus FE. Next, we are going to compare the distance between the two lenses at normal adjustment. Next, we are going to compare the object distance. For telescope, our object distance is at infinity. But for compound microscope, our object needs to be placed in between F and 2F. Alright? And it has to be for our objective lens. I'm going to jot down O here to represent objective lens. And lastly, we are going to compare the image formation. For telescope, the first image formed by our objective lens is real, inverted, and magnified. But for compound microscope, the first image formed by our objective lens is real. This should be diminish. Alright, for telescope, the image formed by our objective lens is real, inverted, and diminished. But for compound microscope, it is real, inverted, and magnified. Next, we're going to look at the second image formed by our eyepiece lens. For telescope, the second image formed by our eyepiece lens would be virtual, upright, and magnified. And compound microscope also produce virtual, upright, and magnified final image. Alright, so make sure you pay attention carefully to the difference here. Telescope, FO is more than FE, but compound microscope is less than FE. For telescope, the distance between the two lenses are equal to FO plus FE. But for compound microscope, it is more than FO plus FE. For telescope, object need to be placed at infinity, but for compound microscope, it has to be in between FO and 2FO. For telescope, the first image is real, inverted, and diminished, read. But for compound microscope, it is real, inverted, and magnified. But the final image for both telescope and compound microscope are virtual, upright, and magnified. Alright, so I hope this comparison table helps you to understand how telescope and compound microscope better. That's it for today. Thank you.